Hello students, in this video let us discuss about collisions. The third long answer from chapter 6, work, energy, power. For future learners, if you can do mathematical part, you practice this. If not, practice work energy theorem, law of conservation of energy perfectly. If collision question is asked also, you are having other two chapters. From there you can learn the long answers and write the long answers well. Okay. So now the question is, what are collisions? Okay. Explain the possible types of collisions. Develop the theory of one-dimensional elastic collision. So collision means, now you will see the cricket game. In cricket game, the interaction between ball and bat will be of very short interval. But bat exerts a very strong on the ball, and we say sixer, four, etc. Means a strong force is acting between two bodies for a short interval of time. That we call it as collision. A strong force acting for a very short interval of time between two bodies is called collision. Two types of collisions are there: elastic collision, inelastic collision. So first, elastic collision means the collisions in which both momentum and kinetic energy are conserved or constant. In inelastic collision, only momentum remains constant. Kinetic energy changes. Okay. Now let us move for one-dimensional elastic collision. So for this, consider two bodies of masses m1 and m2, right? Two bodies, one of mass m1, other of mass m2. Okay. Let they are moving with velocities u1 and u2. Let m1 is moving with u1, m2 is moving with u2. This is before collision, right? Now they collide. Okay. Now this is at the time of collision. Okay. And after collision, they travel with velocities v1 and v2. This is elastic collision. They separate. m1 travels with v1 velocity, m2 travels with v2 velocity after collision. Okay. Now let us enter into mathematical part. So here we are applying, we have to find the final velocities v1 and v2. For that we are using law of conservation of momentum as well as law of conservation of kinetic energy. So first, from law of conservation of linear momentum here. What is the formula for linear momentum? Mass into velocity. Okay. So it says that momentum, sum of momentum before collision is equal to sum of momentums after collision. Right? So before collision, mass into velocity. The first body's momentum m1 u1. Second body's momentum m2 u2. Sum of or total. So total momentum before collision m1 u1 plus m2 u2. That is equal to total momentum after collision. So this body's momentum m1 v1. Other body's momentum m2 v2. Formula is mass into velocity, momentum formula. And total momentum after collision m1 v1 plus m2 v2. Right? Now next what I am doing means, once I am bringing to one side, twos I am taking to that side. So what I will get? m1 u1, this one minus m1 v1. Here m2 v2 is there. I am bringing this to RHS minus m2 u2. Right? Now here I can take m1 common. So u1 minus v1. And here I can take m2 common. v2 minus u2. Put it as equation 1. This is important, equation 1. Right? Now next, from law of conservation of kinetic energies. What is kinetic energy? Half mv square? No. So for the first body, so what it says? Kinetic energies before collision is equal to kinetic energies after collision. So half mv square, no, first body half m1, what is the velocity? u1 square plus total kinetic energy. Second body half m2 u2 square. That is equal to kinetic energy after collision, total kinetic energy. Half m1 v1 square plus half m2 v2 square. Nothing but from here only I wrote before collision. The kinetic energy of first body half m1 u1 square. The second body half m2 u2 square. Total kinetic energy this plus this. Right? Now after collision, first body mass is m1, velocity is v1. So half m1 v1 square plus second body's mass m2, velocity v2. Half m2 v2. Total kinetic energy these two plus. Okay. Now as usual, once I will write on one side half m1 is 1 square. This I am bringing to LHS. It becomes minus half m1 v1 square. That is equal to this here half m2 v2 square. This I am bringing to RHS. It becomes half m2 u2 square. Now here you can take half m1 common in these two. So what is remained here? u1 square. And what is remained here? v1 square. Here also you can take half m2 as common. What is remained here? v2 square. And what is remained here? u2 square. Half strikes off. Now what is remained? m1 u1 square minus v1 square equal to m2 v2 square minus u2 square. Put it as equation 2. Clear? Okay. Put it as equation 2. Okay. Now, equation 2 divided by equation 1. LHS only, RHS only, you divide. Okay. So now, what is equation 2? m1 u1 square minus v1 square divided by, what is equation 1? m1 u1 minus v1. I will show. m2 v2 square minus u2 square is equal to, divided by m2 V2 minus U2. Right? Here is our equation 1. LHS M1 U1 minus V1, RHS M2 V2 minus U2. That only there I divided. I divided LHS by LHS, RHS, RHS only. Right? Clear? Now, in mathematics we are having a square minus b square. We can write it as a minus b into a plus b. If you remember, no need of writing in the exam. If you don't remember, just practice. In mathematics we will have this formula, no? Here we are applying. M1 strikes off, M2 strikes off. Now what is remained? U1 square minus V1 square by U1 minus V1. V2 square minus U2 square by V2 minus U2. Alright. Now this formula I am applying here. What I will write? U1 minus V1 into U1 plus V1 by U1 minus V1. This is equal to, here also I am applying this formula only. V2 minus U2 into V2 plus U2 divided by V2 minus U2. The same term strikes off. Now what is remained? U1 plus V1 is equal to V2 plus U2. Put it as equation 3. Right? Now I can write, or let us take equation 3 afterwards. Now I can write this as V1 is equal to U1 I am sending to this side. V2 plus U2 minus U1. Now put it as equation 3. Now let us substitute these 3 in equation 1. Okay. Now I am writing first equation 1. What is our equation 1? M1 U1 minus V1 equal to M2 V2 minus U2 is our equation 1. So now I am substituting this V1 here. So what I will get? M1 U1 minus, what is the V1 in place of V1? V2 plus U2 minus U1 I substituted. That is equal to M2 V2 minus U2 as it is I wrote. Now M1 U1. This becomes minus V2. Minus plus minus U2. Minus minus plus U1. That is equal to M2 V2 minus U2. Right? Now multiply with M1. So what it becomes? M1 U1 minus is there. M1 V2 again minus. M1 into U2. M1 U2 again plus is there. Put plus. M1 U1. Now multiply this also. M2 into V2. M2 V2 minus is there. Put minus. M2 into U2. M2 U2. Clear? Now next. Now here V2 I am placing here only, and this V2 I am taking to this side, and this U2 I am bringing to this side. So what happens? M1 U1. So forget about this. What is next? Minus M1 U2 plus M1 U1. This I am bringing to this side. What it becomes? Plus. Here minus is there, no? Plus M2 U2. That is equal to, here what is there? M2 V2. Here what is there? Minus M1 V2, no? So it becomes plus M1 V2. Alright? Plus M1 V2. Okay? So now, see. Okay? Now, here I can write 2M1 U1. Okay? Now here, you see here, U2 is common in these two terms. Plus U2. First plus sign I am writing. M2. Here what is there? Minus M1. That is equal to M2 plus M1. Here V2 common we can take. V2. Right? Now bring this to this side. What you want to find? V2. So V2 equal to Now how we will write? First I am writing this term, m2 minus m1 by m2 plus m1. Here u2 is there, u2 plus 2 m1 by m2 plus m1. Okay, here u1 is there, right? Or if you want to involve another step, first how we will do? v2 equal to overall divided by m2 plus m1. Then separate it, your wish. Now this is v2. Similarly, v1, a small logic, where 1 is there, you place 2. When 2 is there, here 2 is there, no, you place 1, minus m2 u1 by this will be same, plus 2. Where 1 is there, you substitute 2. Where 2 is there, you substitute 1. Right? This is v1. m1 minus m2 by m1 plus m2 u1 plus 2 m2 u2 by m1 plus, m2. m1 plus m2. So this is one-dimensional elastic collision. So this is about the third long answer in chapter 6. So I think I made this lengthier mathematical part easier for you. Just practice it perfectly so that you can get full marks. Thank you for watching my video. Yours, Reshma Physics.